solving proportions using cross products, a la Schmuck. Leonard the Leprechaun has run into some financial troubles and needs to sell his pot of gold on eBay.
I seem to be in a pickle.
The pot contains shamrocks and golden coins. The ratio of shamrocks to coins is 3:2, meaning that for every 3 shamrocks he has in his pot, he has 2 coins. If there are 36 coins, what is the total number of items in the pot? We want to find the total number of items, so let's call our variable I. Now let's set up our ratios as coins to total items. We can also write that as a fraction. The number of coins is 36, so coins over total items is the same as 36 over I. Now let's set up an equivalent ratio for coins to total items. We have 2 coins to every 3 shamrocks, giving us a total of 5 items. So we know that 2 out of every 5 items are coins. Because we have found the equivalent ratio, we can set up a formula. 36 over I equals 2/5. Now we just solve for I. Using the method of cross products, we know that 36 times 5 will equal 2 times I. 36 times 5 in California equals 180. So 180 equals 2 times I. Next, divide both sides by 2 to get I equals 90. The total number of items in Leonard's pot is 90.
Finished eating with his family at a restaurant. The total bill for his family was $52, and Rick was pretty impressed with the service, so he's going to leave a 25% tip. He wants to know the total amount he should leave at the table. Select the equations Rick can use and determine the total bill including the tip. So the unknown thing, the thing that we should figure out, is the total amount he should leave at the table. So let's just call that X. Now there's a couple of ways we could think about it. We could think about it as the ratio between the total amount he's going to pay and the actual bill. The ratio between the total amount he's going to pay and the actual bill. That should be the same thing as the ratio between the respective ratios. So you could view the actual amount of the bill as being 100%. That is 100% of the bill. But he doesn't want to just pay 100%. He wants to pay 100% plus a 25% tip. Plus 25% tip. So we could rewrite everything that I just did here as X over 52 is equal to 100% plus 25%. I could write that as 125% over 100. Over 100%. Now if we look at the choices here, this looks exactly like this. If we just swap the left and right hand side, we get 125% over 100% is equal to X over 52. So we can select this one. And once again, this makes sense. The ratio between what he's going to pay with the tip to 100%, or the percentage that he's going to pay if you include the tip, relative to 100%, is going to be the actual amount he pays relative to the actual bill. Now let's see if any of these other ones make sense over here. So here he says it's the ratio of the actual bill to 100% is equal to the ratio if you're going to pay to 125%. Now this makes sense too. Let me just rewrite it again for emphasis. So here they're constructing a proportion where you have the ratio of the total bill, and you're saying, hey, look, that total bill is 100%, and we want to find, actually let me write that in blue. The total bill is 100%, and we want to see this ratio should be the same as the ratio between the actual amount we're paying and 125%, and 125%. So you increased this by 25%, well, you're going to have to increase this by 25% as well to get the actual amount that you're paying. So this makes sense as well. Now what about this? The ratio between 100 and 125% should be equal to X over 52. Now this does not make sense because this is the ratio between kind of the full price without paying the tip and the tip. Well, here is the tip and the full price. So if you swapped these two, if you wrote this as 52 over X, then you could check this. But here, you're not finding the ratio between the corresponding things, so I would not check this one there. But either way, our last thing to do is actually to figure out how much tip Rick should leave. So we need to actually solve for x. And we could go back to this original equation here, and if we multiply both sides by 52, we get x. X is equal to 125 divided by 100% is 1.25. 1.25 times 52 times 52, and then I can just multiply that. Let's see, 52, 4 goes into 52 13 times. So this is going to be 1. Well, actually, let me just divide. Let me just multiply that. I don't want to make a mistake here. So 1.25 times 52 times 52. 2 times 5 is 10. 2 times 2 is 4 plus 1 is 5. 2 times 1 is 2. Let's throw 0 down here because we're now multiplying by 50. 5 times 5 is 25. 5 times 2 is 10 plus 2 is 12. 5 times 1 is 5 plus 1 is 6. So we get 0. Let's carry that 1. We get a 5. We get a 6. And we have two numbers behind the decimal point. It is 65. And that's right. That's 52 plus a fourth of 52, which is 13. 52 plus 13 is 65. So he should leave $65 if we want to include the tip. 3 cups of oatmeal. How much flour is needed for a big batch of cookie that uses 9 cups of oatmeal? So let's think about what they're saying. They're saying 2 cups of flour. So 2 cups of flour. 2 cups of flour. For every 3 cups of oatmeal. For every 3 cups of oatmeal. For every 3 cups of oatmeal. So for every 3 cups of oatmeal. For every 3 cups of oatmeal. And so they're saying how much flour is needed for a big batch of cookies that uses 9 cups of oatmeal. So now we're going to a situation. Now we're going to go to a situation where we are using 9 cups of oatmeal. Let me write it this way. 9 cups of oatmeal. 9. And I'll show you a couple of different ways to think about it, and whatever works for you, that works. So first of all, the one way to think about it, so we're wondering, we're going to say, look, we know if we have 3 cups of oatmeal, we should use 2 cups of flour. But what we don't know is if we have 9 cups of oatmeal, how many cups of flour do we use? That's what they're asking us. But if we're going from 3 cups of oatmeal to 9 cups of oatmeal, how much more oatmeal are we using? Well, we're using 3 times more oatmeal, right? We're multiplying by 3. 3 cups of oatmeal to 9 cups of oatmeal, we're using 3 times the oatmeal. Well, if we want to use flour in the same proportion, we have to use 3 times the flour. So then we're also going to have to multiply the flour times 3. We're going to multiply the flour times 3, so we're going to have to use 6 cups of flour. We're going to have to use 6 cups of, ignore that question mark, 6 cups of flour. Another way you can think about it, that answers their question. That's how much flour we need for a big batch of cookies that uses 9 cups of oatmeal. The other thing is you could set up a proportion. You could say 2 cups of flour over 3 cups of oatmeal. 3 cups of oatmeal is equal to question mark, and I'll say, instead of writing question mark, I'll put a variable in there. I'll say is equal to a question, actually let me put a question mark there just so you really understand, is equal to a question mark in a box, number cups of flour, over 9 cups of oatmeal, 9 cups of oatmeal. And so I like this first way we did it because it's really just common sense. If we're tripling the oatmeal, then we're going to have to triple the flour to make the recipe in the same proportion. Another way, once you set up an equation like this, is actually to do a little bit of algebra. Some people might call it cross-multiplying, but that cross-multiplying is still using a little bit of algebra. And I'll show you why they're really the same thing. In cross-multiplication, whenever you have a proportion set up like this, people will multiply the diagonals. So when you use cross-multiplication, you'll say that 2 times 9, so 2 times 9, must be equal to question mark times 3. Must be equal to question mark times 3. Must be equal to whatever is in this question mark, the number of cups of flour, times 3. Or we get 18. 18 is equal to whatever our question mark was, times 3. So the number of cups of flours we need to use times 3 needs to be equal to 18. What times 3 is equal to 18? You might be able to do that in your head. That is 6. Or you can divide both sides by 3 and you will get 6. So we get question mark in a box needs to be equal to 6 cups of flour. Same answer we got through kind of common sense. Now, you might be wondering, hey, this cross multiplying doesn't make any intuitive sense. You know, why does that work? If I have something set up like this proportion set up, why does it work that if I take the denominator here and multiply it by the numerator there, that needs to be equal to the numerator here times the denominator there? And that comes from straight up algebra. And to do that, I'm just going to rewrite this part as x, just to simplify the writing a little bit. So we have 2 over 3 is equal to, instead of that question mark, I'll write x over 9. And in algebra, all you're saying is that this quantity over here is equal to this quantity over here. So if you do anything to what's on the left, if you want it to still be equal, if the thing on the right still needs to be equal, you have to do the same thing to it. And what we want to do is we want to simplify this, so all we have on the right-hand side is an x. So what can we multiply this by so that we're just left with an x, so that we've solved for x? Well, if we multiply this times 9, the 9's are going to cancel out. So let's multiply the right by 9, but of course if we multiply the right by 9, we have to still multiply the left by 9. Otherwise, they still wouldn't be equal. If they were equal before being multiplied by 9, for them to still be equal, you have to multiply 9 times both sides. On the right-hand side, the 9's cancel out, so you're just left with an x. On the left-hand side, you have 9 times 2/3, or 9 over 1 times 2/3. Or, this is equal to 18 over 3. And we know that 18 over 3 is the same thing as 6. So these are all legitimate ways to do it. I want you to understand that what I'm doing right here is algebra. That's actually the reasoning why cross multiplication works. But for a really simple problem like this, you could really just use common sense. If you're increasing the cups of oatmeal by a factor of 3, then increase the cups of flour by a factor of 3.